بسم الله الرحمن الرحيم رب زدني علما.
Okay, the next thing we'll try to see the lab prerequisites to verify the NAT configurations. We'll try to understand the prerequisite. So configure the IP addressing. So in this example, I'm going to use a router 1, which is also my NAT device. So I'm going to assume this is connecting to the service portal. Okay. And we have some internal users like 192.168.1.subnet, which are my private users. And when they are sending a traffic from this source and trying to access some servers here, so I'm simulating some servers. I just connected a router and then a switch with some computers here. And actually these are servers, and these servers will be simulating my host on the internet. So I don't have a real real internet connection. So basically this is my topology here, which I have already connected. Okay, so typically in the production scenarios, the NAT can be either configured on your router or on the service portal, depends. Like if you take in a normal home internet connections, let's say in your building you have, these are all apartments users, let's say, so all the users, maybe you have in a home internet connections we don't do NAT. So basically what happens is in the home internet connections, these are our wireless routers which we use. They all go and connect to the kind of switch, and from there it connects to the service portal device, and the service portal is responsible for translating the NAT. And of course this service portal is again assigning the IPs to your routers. There's a process over there through DHCP again. So basically the NAT is done on the service portal side, especially on the customer environment. Okay, so if you take the same example in our company scenario, in a production network scenario, then basically these are all the users who are connecting in my company, and this is my gateway. Okay, so typically in your company scenario it will be like this. So this is your LAN, and we connect to our gateway, and from there we connect to the service portal. Of course you get some public IP here, let's say 100.1.1.1. So what I'll be doing is the NAT is configured on my router. So what we'll do is we'll get some public IPs. Okay, so we get some public IPs from the service portal. We purchase the range of public IPs. Let's say if I'm using /30 also, I get 4 public IPs. In that 2 I cannot use, the first and the last, and maximum I can use 2. So I'll be using 1 for my internal web server, and then I'm going to translate with the Static Nat. And the rest of the users, they all will be able to access internet. So these are the users, they all will be translating using the PAT, port address translation, let's say. So you can have more than this. This is a kind of simple example to understand. And here the NAT is done on our own router. Okay, so basically what we want is, because in production scenarios, especially when you have thousands of users, whatever the concepts we use like in our home connections, that's not going to scale. So as we are using a dedicated Cisco routers or any other vendor routers, and or maybe a firewall which will be doing NAT for us. Okay, so this is kind of a production scenario what you will see. And in my example, I'm going to simulate the same way because I don't have a real ISP connection. So I'm going to simulate a router here. This router is simulating my service portal, and from there the traffic is going over there. So the first step is I'll be configuring the Static Nat. So basically what I'll do is we'll try to configure the Static Nat. The prerequisite first we'll see. Okay, so the first thing we'll try to see configure the basic IP addressing here. Of course, the IP addressing you have to configure as per the diagram. So we assume this is your public interface where we are connecting to the internet. And the next thing is we'll be configuring the routing. The routing is required. Basically, what we need is we need to make sure that this 192.168.1.subnet should be able to reach these servers. So reachability is important. So in the real scenarios, the reachability will be in a different way. Like in the real scenarios, we'll be configuring some kind of default route, and this default route will ensure that when the user sitting in my LAN is trying to access any server on the internet, the router do not have a route, and automatically it is going to route the packet over the service porter, and the service porter knows exactly where is that server. So basically this service porter is going to maintain some kind of BGP routes, some kind of routing protocol used, and it knows where is that actual server he's trying to access and send the request to the server. So we are not seeing this. In this case, in our example, there's no BGP. This router knows this network through connected, okay, because they are connected networks. So in our case, we are not using BGP. Again, as I said, we are not simulating the exact DL scenarios. Okay, so this is something beyond the scope of the exams, CCN exams here. So, which means the traffic will reach the actual server, and when this server replies back, so it will reply to the service porter, and that service porter will again need to know exactly where is that server, means how to route the packet, which means it must have a route of the customer. But whereas in our case we have translated this 192.168.1.subnet, let's say, which means this service porter should have a route to route the packet back to this one, right? Either static or dynamic, we learn the routing. But normally this is not possible because this is your private IP, and there is a possibility that multiple customers will be using the same private IP, right? And of course we don't use dynamic routing again. So basically the service porter will have a static route for the public IP. So whatever the public IP we have used, basically the service porter will have a route or static routing for that public IP. So which means if you check this scenario here, in my case, from my router towards the service porter will be configuring the default route, and the packet will route and reach the server, return back, and the service porter will have a static route for the public IP, whatever is used for translation. So in my example, I'm using a 50 node network. That is a network I'm using. Assume this is the network which is allocated by service porter. So I'll be using this public IP, okay? So that's how it's going to be, the setup. This is your prerequisite for all the types of NATs. So let's try to quickly set up this so that, when we do the labs, this configuration is ready. So the physical connections are okay, and I think the IP addresses already configured on the devices. So on the end devices, I do have the IP configuration. Okay, so let me see the configuration on these routers, and I think I didn't save this configuration. So let me quickly go and configure this. So I'll start with the router 1. So if I say show IP interface brief, I have no configuration. So what I'll be doing is I'll be configuring the IP, and then also the next thing I'll be configuring the default routing. Two things at once. So G0 by 0 interface, and then the IP address is 192.168.1.100. That is the gateway address. And then on serial interface, I'm going to assign the IP address of 100.1.1.1. In the production scenarios, this IP will be given by the service porter. So most likely this IP will be a public IP, and typically decided by the service porter. So that it can be a static IP, or the service porter may use a dynamic DHCP server to provide the IP address for this device. Okay, so here we assume it's a static IP and assume this is the address what is told by the service porter to use. So we'll be using that. Okay, so the next thing is we'll configure the default routing 0000, and the next hop address is 100.1.1.2. So what we are doing is we are going to configure the default route here 0000 towards 100.1.1.2, and then we'll save these configurations. So probably the next time when I want to load this topology, I don't need to do it again. Okay, so we got these configurations on the router 1, and the same way I'm moving on to the next router, that is your service porter router, hostname ISP. And if you verify the IP configurations, I don't have IP configurations here. So I'll quickly configure as per my topology. So I'm using this address. So this is kind of simulating, kind of service porter here. In the real scenarios, it will be different. And the IP address is 101.1.2 with /24 or / whatever the / value, it's up to you. So let's say show IP interface brief. Anyway, the interface is up even if I don't give the clock rate. So let me just quickly verify the reachability between the two routers just to confirm that we do have reachability, and as well as I do have reachability to the servers. Okay, 201.1.1, right? That is the IP address. 201.1.2. That's an IP address. Again, in this scenario, this router is connected directly to this one. That's the reason we do have reachability. In the real scenarios, again, these servers are not in the service provider network. They will be placed somewhere, but this service provider knows exactly how to reach. So that is through BGP routing. Okay, so this is my setup. You can save the topology normally up to this point so that, you know, next time when you're trying to do the labs for let's say for your static NAT or dynamic NAT or any other NAT, you can go with these initial configurations. So the next thing is, let me see if I have reachability between the LAN user here to this one. So will I have reachability? Let me see. So meantime, just try to tell me if it is possible. Let me try to ping. Again, one thing I actually forgot. I forgot to write the static route here, the reverse static route. Now, again, as I said, there will be a static route. You can either configure static route directly to this one. But again, we'll be translating this address later on. So there's no point in writing the static route for this. So I'll be writing a static route for 50 network, which is the public address range. So I'll be using the public IPs in this range of 50.111/24 subnet. Okay. So let me just quickly go and configure a static route here. So I'll say IP route 50 network /24, and it is 100.111. So this is for the reverse routing, so that the packet should come back here. So save the topology up to this point. So will I have reachability now? Let me see. So still you don't have reachability. And the reason is simple. If you know the routing concepts, what we have seen, you can easily troubleshoot this. Because when the packet is initiated, the source address is 192.168.1.1 and the destination address is 200.1.1.1. That's what we are trying to do here. Now in this case, the packet will route to the gateway. And this gateway will say, okay, based on the default route, I'm going to send a packet to this ISP. And this ISP router says, okay, 200.1.1.1, you can go to this host. The packet goes up to here. So now the packet is going to return back. So when it is returning back, the source address is 200.1.1.1 and the destination address is 192.168.1.1, right? Because we didn't translate. Remember, we did not do any translations. So it's a normal route packet. So when the packet returns back, it will say, it will send the packet to the router. That is ISP in our case. So it reaches the ISP. And now this ISP will check the routing table. Do I have a route for 192.168.1. network? I don't. Do I have a route? So if you go to the ISP here, if I say show IP route, we do have a route for 50 network, but we don't have a route for 192.168.1. network. So if you write a static route for 1. network, that should work. That will work normally. Okay. But in our case, as our requirement is the NAT, and this NAT device is going to translate this 192 network to public IP 51.1.1, which I didn't do that. And that's the reason we don't have reachability now. But after I implement the NAT, you must have reachability, because after you implement the NAT, what happens is this destination address will change to public IP because of the translation. Okay, when the packet initiates, it will be this. But when it goes outside the service provider, this address will change to 51.1.1. So now there will be a difference now. Okay, so once I implement the NAT, you should have reachability as per this routing. Okay, so just ignore this right now, because don't waste your time in just going to fix it, because this is not going to work unless you do the NAT or unless you change the routing to the 192 network. But here, as I said, our goal is to verify the NAT. So that's the reason I do have a static route configured on the service porter for the public IP what I decided to use. Means whatever is allocated by the INA depending upon your region.